YouTube Live, our first YouTube Live. We're going to do some practicing on our big flange here. We're in our training center here in Mahwah, New Jersey, and we're going to work on doing some training exercises on the flange, how to keep alignment, and how to take everything apart and inspect everything. So right now we have our two students here. We have Cobus and Molly. They're going to be doing all the action today, and we're going to start off with taking the entire flange apart. It's 16 bolts. So we're going to take the entire flange apart, inspect everything, and then replace whatever we have to replace, and start putting it back together and do some measurements. All right, so come along. All right, guys. So same thing like we were just talking about before. What we're going to do is start taking all these apart. So all these should be nice and loose. So we can start taking these apart. We'll put them on the cart here, and we'll start cleaning them off, inspecting the threads, inspecting the nuts and the washers, making sure that everything is good to use. All right? you'll see that the safety hook is here, so the flange won't be able to fall, right? This is nice and loose here, but flange won't be able to fall on anything. Once you get those out, you'll be able to get the gasket out. Yeah. Fancy gasket. What we have to remember with these gaskets here is that these gaskets are always a mirror image of the flange faces. So one of the things that they want to do when they're checking this, inspecting this, they want to mark the flange and mark the gasket as they're taking out. Which side came out from the 12 o'clock position, what side is your active, what side is your passive. And you really want to make sure that any kind of grooves or anything that you see, any bad markings that are in here, will give you that mirror image of the other side of the flange here. So you'll be able to tell if you have to replace a flange face or not. So that's one of the key aspects of this exercise, is to inspect everything and look at this mirror image of this gasket to see if there's any kind of markings on here that has to be replaced, right? This flange is nice. It's set up where you can open it up using this crane, right? This is just a practice flange here. So you can see inside. We can inspect the grooves on the inside of here. We can make sure that the raised face part of this flange here is nice and flat, where it's not beveled over at all. We can make sure and inspect all the holes here. Same thing on your opposite side of your flange face there. So right now they're just going to be cleaning it off, and then they're going to be cleaning off all of your hardware as well, and then inspecting all the hardware. Again, this is just an exercise to do alignment, but we're checking everything, inspecting everything that's on that flange first. So how does your flange faces look? Do they look like there's any bad markings on their inside? Anything that would make, if this was a pressurized vessel, anything that would make this leak out?
Feel right here.
Well, it's kind of hard to feel here. That is a little burr that's on here. But visually, we're going to inspect this really well and make sure that everything on here, all these little grooves are nice and concentric all the way around. There's no scratches or gashes that go through here. There's no pitting or anything on the sides here. So if you have some gashes here and some pitting, what you would want to do is make sure that it's not half the thickness of your sealing surface. If it's half the thickness of your sealing surface or more, that's when you would really want to try to reface this flange, or just cut this flange off and replace it with a new one. Now, you can reface flanges, but it is a little bit difficult. You need special machinery, special tooling for it. So when you're going through these and inspecting them, you really want to figure out what kind of tooling you could use for this, or if you just have to replace the entire flange face. Right? Again, this is a training module, so we have these, we use these quite a bit, and they're, you know, pretty damaged, right? And that's kind of what we look for. We want people to inspect them and make sure that they see that it could be damaged and what they should do if it is damaged. Right? So you do that to both flange face sides, right? These are a raised face flange, so it is this lip that's here all the way around. Right? And this is your sealing surface here. There should be nice concentric splines all the way around it, nice concentric grooves that go all the way around it without any pitting or any kind of gashes or scrapes or anything like that. If you have a gash or a scrape from the inside here, you know it's just going to get worse, depending on the media, especially if it's steam. Steam likes to really creep through gashes and cuts very fast, so it'll, you know, creep through the rest of this flange and creep through that gasket pretty easily. All right, so you guys look good on this side here. So now we're going to go all to the hardware, inspect all the hardware. We're just going to wipe it all down. You can clearly see how some of these threads here are actually flattened out. Right? So since this is just a training exercise, we're gonna clean them all off, right? You would generally replace all of these before putting that flange back together. But again, what we're really concentrating on this exercise is making sure that we get the flange, both sides of them aligned, right? So we're not really worried about our torque values for this exercise because we want to make sure that we're working on our alignment, how to do center line alignment and how to keep everything nice and parallel. All right, so go ahead and wipe those all down. We'll inspect them and then we'll also start putting everything back together with a new gasket.
Also check your bolts for stretching.
Yes, yeah, you will want to make sure that there's no yielding. If you start seeing hourglass shape to it, that would definitely be a yielded bolt.
Maybe this one's no good because these are not great.
Yeah, a lot of these are starting to go bad for sure with these flat edges here. All right.
So replace this one?
Well, we're not going to replace any of these because we're going to work on the alignment for this. So we're not going to worry about the torque values for these because we're not going to be torquing these yet. We're just going to be worrying about how to align the flange faces. So we're going to put them all back in there just so we can align them correctly.
So we're inspecting them, realizing that they're not all great, and
Yes.
we're putting them back anyway.
Yeah.
Okay. Yeah. New bolts. Because we were told to. I didn't follow instructions. But we're gonna replace some of them. You can see that some of these threads are jacked up. The crests are worn down, and they're spaced out a little weird, which means the bolt is likely yielded.
All right, so we will replace all of these, but definitely, definitely make sure we clean off all the washers too to inspect the washers and the nut faces as well.
All of them, I think. Fog it up. I think Hardy's gonna get us new washers. These are kind of jacked up.
It's fine.
Are you finding that you have J washers over there? Instead of all the reduction washers? Did you touch yours up?
We have both. We don't have a lot.
Oh, yeah. I like it.
the code for that?
I think I do.
Here's one that's got a little bit of a thread that's starting to go.
Yeah, this hardware is pretty banged up during class. Wishing you had a little stand right about now. I was just watching. Just watching. Yeah. Good grief. We're running out of semi-clean spots on the rag. Hooray!
All right, guys, so if you're just joining in, what we're doing now, we're doing an exercise on aligning a flange. Right? So we have two phases of the flange. We're inspecting the flange, we're inspecting all of the fasteners that we have with this flange, and then we're replacing anything that's bad. What they found out so far from taking it apart is that some of the bolts are yielded. So we're gonna replace these studs with brand new ones, and then we're gonna also replace some of the washers here and the nuts. This exercise is really just meant for alignment, but we're gonna replace these because we are gonna be torquing them down. So once they get everything cleaned off, we're really gonna know which stuff to throw out. We're not gonna reuse these. This is just a test flange here. We're gonna put everything brand new into it. But these test flanges here, we're gonna go up and do our 3 passes and then our 4th check pass with it. And really what the whole point is to inspect everything and make sure everything's nice and aligned.
So we clean stuff we're not using. Okay.
Well, we want it nice and clean so when we throw it in the bin, it doesn't get everything else nice and greasy, right? Yeah.
Thread is starting to come out.
Who is? Yeah, that's definitely a bad thread to that there. You see that the thread's starting to break off here, right?
There was one that I've seen.
Yeah. Yeah, some indentations here. This looks like it was definitely beat up quite a bit, right?
Okay.
Good catches. It's a good inspection.
Even if we were,
Yeah.
if we were gonna reuse the washers, we would probably have to actually clean them because some of them had
Yeah.
lubrication on the knurled side, which shouldn't be.
So you can transfer all the bad ones over here. We'll put all the bad ones in bins, and then we'll put all the new ones in there.
I mean, are we just doing all new?
Yeah, we'll do all new studs and nuts with those.
You want me to get a milk crate? So we don't put them all over the place?
You can just put them here. I'll
Okay.
throw them over there.
Okay.
What?
What about the nuts? Are we replacing them?
Yeah, yeah. These boxes have the brand new nuts to them too. Yeah, I'll do it with the new ones because it'll be easier to see them.
I'm gonna use them.
Yes, we'll use the back. Yes. So we use the back box and get them from nice new washers too. And then the new gasket is right to the left of you. So what we're going to do now is put everything back, assemble everything back together. We're using new hardware for it, so we're going to lubricate it. But first we're going to make sure we set up the flange. Right? So we're going to swing this flange back over. Again, this is our test flange, so we're going to swing this back over here. We're going to start to put some studs on the bottom of the flange. That way we can cradle our gasket, our new gasket inside of there. And then once we cradle that new gasket inside of there, then we can start putting our fasteners all around and properly lubricating them after they've stabbed the flange. So once they're through the flange. All right?
It's in.
Now, when you're doing this, you also want to make sure that all your labels are facing outwards. So where it says B7 on here, you want to make sure that B7 is always facing outwards. Same thing with your nuts. And when we put our washers on here, we want to make sure that our knurled side of the washer, that knurled portion, is always going to be facing against the flange. And that flat portion there, that flat portion is always going to be facing against the nut. So it'll be right against the nut face, these two surfaces here. And we're also going to lubricate these. Greasy.
This is why I need to wear black.
The backup washers that we're using for this system here, it is knurled on both sides. This is meant for the passive side of the flange. It just goes back here. And what this does is act as extra friction. So with this system here, you don't need a backup link. You have this extra friction here and it applies to the flange once you start compressing everything together. Now with the system here, since you see that there's a crane, right? We have this big eye bolt. If you use the adjustable wrench here, you can fasten this eye bolt here to go up and down, right? So go ahead and use that adjustable wrench on there. If you have to go up with it, down with it. Right, that will be part of the aligning process. We want to make sure that this center line is within 1/16 of an inch. That center line is how both flange faces are going to sit towards each other. What you could also see with this flange here, we already have our bolting pattern into place. That is the +4 method bolting pattern that we are using. So we already got our 1, our 2, our 3, and our 4, and then we're adding 4 to the previous number. That is how we're getting this bolting pattern. All right, so now let's get the brand new gasket in over there. We'll start to sneak that in. And we'll start to align that up using all of our nuts and bolts here. So with the backup washer here, you can actually see it, how it's on the flange already, how it's on the system. What this backup washer does is has knurls on both sides of it, and these knurls act as extra friction. So when you're putting this on to that flange here, instead of using a backup link, when this nut wants to rotate around on you as you're tightening your active side here, this nut will act as this washer will act as extra friction here, and it'll keep you from moving that back nut around. So this system here, this washer system, helps you where you don't have to use a backup link or any other kind of backup system where the nut's not going to turn. So as you're tightening the active side, this passive side back here has plenty of friction applied to it where it's not going to move around on you. You wouldn't want to mark it right now, definitely when you're taking it apart. Yeah, when you're taking it out, you would want to mark it, just so you can see, since that gasket is that mirror image, you want to be able to mark that gasket that's inside of there once you're taking it out. Right? Yeah. All right. Yep, so just keep an eye on the markings. You always want to make sure, yeah. Yep, just want to make sure that all those markings are on the outside. And that includes the nut as well, right? The nut has markings on it, so you want to make sure those markings are facing outwards. That way you have nice flat surfaces hitting against your washer.
them. Thanks.
And you see with the crane system here, that's on the flange, they don't have to put nuts on the active side quite yet. So this is a nice system, but again, this is just for training and for exercises. So right now we're just doing that exercise on how to properly align these flange faces together. We will be lubricating these and making sure that we have 2 to 3 threads showing on the outside of the nut face. So those are the other markings on there. We want to make sure that these say the B7 on them. Right, so I'm just going to flip this around real quick. So what they're double checking here right now is that they're making sure that all of these studs say B7 on the outside. This is the type of stud that it is. You always want to make that B7 of what type of stud that is, or you want to make sure that marking of what type of stud that is always facing outwards. That way anybody that's coming onto it can see exactly what fasteners they're using. So everyone who's watching right now, this is an actual training class. What we're doing right now is an ASME class. Here at HYTORC, we do ASME classes. That's the American Society of Mechanical Engineers. We do 23 different classes. So right now we are doing the bolted joint integrity class, which this focus for this exercise is concentrating on the alignment of flange faces and making sure that you stay within tolerance as you're tightening these together. So if you want any training or any information about training, hit up HYTORCtraining.com. That's not it? HYTORC/training? Yep, okay. HYTORC/training.com.
HYTORC.com/training.
Okay.
You do it.
Ugh.
Got one? I believe now we are good.
All right, so now since you're pretty much all set up, right, we're gonna start the lubrication process. What we could do is make sure that you have somewhat of an alignment here. You can kind of see that these are not so much aligned on our center line here. So you wanna try to adjust it just a little bit here. And then we can start to put our washers on and then lubricate properly. So in PCC1 is the standards that we're actually going for on here. These are the ones that we're abiding by. So in PCC1, which is part of the ASME organization, their standard, we want to make sure that we lubricate fully around the threads from root to crest, the entire distance of travel for the nut. Right? So we may have to, on the passive side back here, you know, give us a little bit more room up top of here because we know we're going to bring this entire flange together. Right? On the active side, we want to make sure that we always have that 2 to 3 threads showing. Right? So we have plenty of room with these studs here. We have plenty of length with these studs here to bring everything nice and evenly together. Yeah, so you know that this will rotate, right? And it'll help too once you kind of have everything aligned in here. You can kind of push it forward, and then we can also use the nuts to properly get it conformed in there. And you might need some, you know, play with the studs here. But, so that's fine. So let's start putting the washers on here and then we'll start properly lubricating. And then we can adjust it as we go along. As we're adjusting it, it's what's called dressing the flange, right? So we're making sure that we have everything nice and uniform. Everything's gonna be compressed. We'll snug tight everything. We'll make sure that we always have those 2 to 3 threads showing on our active side. So as we were just showing before, the HYTORC washer system is developed where there's knurls on one side and it's flat on the other side. Those knurls are going to go against the flange face and the flat side is going to go against the nut face. Right? All right, so now we have all of our washers on. Now we can properly lubricate. Right? One trick to do is that if you take your nut here, right, you see that you're going to have at least that distance. We want to make sure that we have the distance of travel as well, right? So we know that we're going to be pushing this in just a little bit, right? So that looks like we are pretty good with our distance of travel to lubricate and with the height of the nut, right? So we'll start lubricating. For this exercise, we are just using a moly coat. This is just an anti-seize lubrication. Again, we're not concentrating on our torque values for these. They're going to be low torque values. The main practice of this exercise is to worry about the alignment.
So you're gonna lubricate from the whole side?
Yeah, so you're going to lubricate the face of the washer here and then all the way around, completely from root to crest, all around it.
take some happy little trees with you.
Don't add any solder, just hit it with the, don't hit it with the soldering iron, and it should work. Don't put any more solder on it.
So we're lubricating these, even though this is a training exercise, we're lubricating these because once you lubricate that fastener, it actually, you're going to exert less force to get the proper load on your bolts, right? You can see here, there's some threads from the paintbrushes here. But we really want to lubricate everything. It is going to give you a different load value, right? So when you're going into it, and if you're doing calculations, you'd be calculating for the nut factor or the K factor, and that's that lubrication factor of this, right? So basically what that means is that with lubrication, you're putting less of a force on there, so you're putting technically less torque on there to get your rotation. You're still going to be putting your torque that you have to for the required application, but you're going to be exerting less force. So if you were doing this by hand, you'd be exerting a lot less force while you're using that lubrication. And it also serves to, preserve the threads from corrosion.
So the amount of lubrication that you put on, does that make a difference?
Absolutely. The amount of lubrication you put on and the type of lubrication you put on, it's going to be very specified for your application by that engineer. So just to go back to it as well, we stab the bolts first. That means we always put the bolts through first, the studs through the flange face first, and then lubricate. And the reason why we do this is because we don't want to pick up any debris or metal shavings or anything that's inside of the flange. That grease will pick it up pretty easily. So we want to make sure that we stab the bolts first and then lubricate them. All right, so yeah, so before we go further, right, these HYTORC washers are designed in a very specific way. We have these lobes that are on the outside here. We have that knurl that you saw that's going up against the flange, and we have that flat side that's going to get that lubrication applied to it. So these washers are actually acting as a reaction system here. Instead of when you have your tool on here, your reaction arm is sitting on your flange face or your opposing nut. Now with the proper reaction system that we'll show in a second, it'll go right up against this washer here, sitting in each one of these lobes. Now you have a pinch point free system, so it's a lot safer where people aren't crushing fingers or anything like that. So it's a lot safer of a system. You're gonna be reacting directly off of this washer here. And that knurl's on that other side here just to cause that little friction here so it doesn't move on you. You can get a nice solid reaction point.
Proceed to lubricate?
Yep, yeah, you can,
Okay.
yeah, you can keep going now with the nuts. We'll put all the nuts on there. You don't have to lubricate every time you're doing this exercise, right? This is just an exercise on mainly the alignment. But if you were out in the field and you were doing this, you would want to lubricate based off of what the application is and you know, what the engineer specified too. Just keep in mind, this is just an exercise, right? This is just a very basic exercise. We're working on alignment here, so we're not really concentrating on the torque values or anything, but we're working on the alignment, so we're setting it up. We're dressing the flange to make sure that we're setting it up properly. But you would really do anything specified by the engineer for that application. And what they're also doing right now is making sure that all the markings here on the nuts are facing outwards. You want to do that so that flat face of the nut is always going to press right up against the flat part of the washer there. Painting the happy trees on the nuts.
You know it's my favorite part.
Gradual steps, yeah.
I'm just making it so there's not quite as much thread protrusion. That's all I'm doing right now.
Again, so we're just dressing the flange. Dressing the flange is just making sure everything is nice and uniform. So we're making sure that we have 2 to 3 threads showing on each stud. That 2 to 3 threads is to make sure that all of your load goes through the entire nut and not just a portion of that nut. Right? You want that load to go through the entire nut, all the threads on that nut to give it the strongest that it could possibly have for that application, for any application. Right? You wouldn't want to have that stud stop 2 to 3 threads inside, because then you can get a pooling effect where there's water that can sit in there, there's contamination that can sit in there, it can rust out a lot easier, and you also don't have that full strength of the nut. So you always want to make sure you get that 2 to 3 threads shown on the outside there. And then on the back side here, they're just making sure that it's nice and snug tight. So they'll be bringing the flange together, nice and evenly compressing into that gasket. All right, so now that they got this pretty much set up, right, there are a few more ones that they have to address, but they got this pretty set up here. We're going to be using the MXT Plus tool. We'll set that up. We're also going to be using our Jet Pro 115 pump. This is our small pump, so we're running one tool off of this. We're just going to be running it using our torque charts here, and we're going to go up to a max torque value of 700 foot-pounds on this flange. When we do this, again, we're going to be working on the alignment. So what we're concentrating on is the center line. So the center line is going to be from one flange face to the other. And we want to make sure that all the way around, we're within that 1/16 of an inch as your max. So we use what's called a high-low gauge to measure that. This high-low gauge is typically used for welding, but it is a great gauge to use for the sides of the flanges to make sure that you're in that center line. So you take the high-low gauge, you would set it to 1/16 of an inch here. That's on the standard side, 1/16 of an inch, right? And you would make sure your flat side here is on your passive side of the flange, and you would really do this around at least four spots of the flange. You want to make sure that that gap is in there, because that gap means that you're within that 1/16 of an inch. If part of the flange on this side, on your active side, is making the whole gauge move up like this, you know that you're not within tolerance. Right, so you would go around at least 4 points of here. If you want to come on this side real quick, you'll go around at least 4 points on here. You see that now on this side, we're actually hitting and we're actually above. You see that there's a little line that's in here, a little air, right? So we know that this flange face has to go slightly in that direction to be within tolerance, right? So again, that's a 1/16 of an inch tolerance. So right now what we're going to do is work on snugging everything nice and tight. We're going to try to align it as best we can, snug it nice and tight, and then we're going to take our measurements and adjust it how we have to be within that tolerance. We're also going to work on the tolerance of the gap here, which should be no more than 1/32 of an inch. If you have more than that, your parallelism could be thrown off. So you could have what's called bird mouthing, and that's where the top piece here, the side piece, wherever it is out of alignment, could be shaped like a V. So we call that bird mouthing. So we're going to make sure that within this entire gap here, you're within that 1/32 of an inch. So your center line is within that 1/16 of an inch. Your parallelism is going to be within 1/32 of an inch. Now, if you were to align this and you see that you have double the width of the gasket that you're using inside of here, if there was an actual pipe here, that would be excessive gap. You wouldn't be able to use that. Just tightening that alone would not be able to get that gasket nice and secure. So really what we're trying to focus on is making sure that we don't have that excessive gap. Now for us, since this is just a training flange, you won't have that pipe here to keep you from getting that excessive gap, right? We're going to be nice and squished up against that gasket there. So we're going to be really concentrating on our parallelism and our center line. So you can sign up for any of these ASME classes at HYTORC.training or HYTORC.com/training. Sorry about that. HYTORC.com/training. You can sign up for any of these ASME classes. ASME, again, is the American Society of Mechanical Engineers. So we do a lot of these classes specifying what we should be really teaching out there in the field. So this one is called bolted joint integrity. She was adjusting the back side of the nuts here to make sure that everything on the front side, this active side, had 2 to 3 threads showing. I believe that was the question. Yeah. Yeah, so she's just making sure that everything here has 2 to 3 threads showing. You see that this one only has about 1, right? So we're gonna adjust back here and make sure we have about 2 to 3 that are showing. Right. All right, so everything looks like you're pretty adjusted here, right? So we're gonna take our initial measurements. We're gonna write down these initial measurements too. Now you can do this one of 2 ways. The 2 main ways, you're gonna pick, just like a clock, you would pick your 12 o'clock position, these are 1 here, and then you would go 3, 6, and 9. Or what you could do is your bolt number 1, your bolt number 2, your bolt number 3, and your bolt number 4. Now you always wanna keep that written down the exact same way. That way you know what measurement is for which area. Right? So that's the key part of that. You always want to measure in the same area for that measurement that you're taking down. So we're going to write these down just so we can make sure that we're within that 1/16 of an inch and that we're within that 1/32 of an inch. Now we don't necessarily have to write down that we're within 1/16 of an inch because all we're doing is putting that gauge on the outside here and adjusting it side by side, right? But that 1/32 of an inch for the gap here, to make sure it's nice and parallel, that's what we're going to be writing down. So again, we're using this high-low gauge, right? We're going to set it to 1/16 of an inch. Yep, that looks like it's there. And then just tighten it there.
Would you like to do the honors?
And then we could just go around. You could do 4 points at least. You know, it's really up to you. You can kind of glide it around as well if you wanted to. Yeah. And then as soon as you see that push up, that flange push up against that high-low gauge, that's where you'd want to start to adjust it.
So that's correct, eh?
Correct. Yeah. You see that gap that's in there, so that's within tolerance.
Okay.
All right.
Okay, so we find the. Okay.
Yeah, so it looks like you're touching just a little bit where it wants to move that gauge to the side, right?
Yeah.
So you're gonna adjust that flange up a little bit, right?
Cool.
So you're just gonna use this adjustable wrench and adjust it up just a hair. It didn't have to go up too much. Yeah, try that. See how it works out. And now you're touching, but now it's not pushing the gauge to one side or another, right? So technically you are still within tolerance, but you could give it another crank up here and just make sure you get that. Right. Yeah, almost.
Bring that a little bit more. Nice batch.
Yeah, oh yeah. All right, now you can see air through there, right? So there is that nice little gap that's in there. So you can go back up to the top side and just measure that again, and also your sides, just to make sure you're within that center line. Now see, you're up just a hair, right? So you want to adjust that back down just a little bit. There you go. Use the right side of the gauge. There you go. So that's the other thing with these high-low gauges. You always want to make sure that you're using the correct side of the gauge. So use that one side of the high-low gauge always on your passive side, and the other side of the high-low gauge always on your active side. And those proper sides would be this would be your passive side and this would be your active side. That way you can move your flange up and down within that tolerance if you have to.
Let's just check the side.
So go ahead, check that side there. Make sure you put it on the right side of the, there you go. Now you can check the other side as well, just to double check it.
That's one. There.
All right, so now our center line is here, we're within tolerance. All right, so that center line again, that's your measurement from flange face to flange face all the way around. So we're making sure that that center line is nice and even all the way around. You're within 1/16 of an inch. All right, so now what we're gonna do is work on our parallelism. So this gap in between everything, we're gonna make sure that this pipe, if there was a pipe here, but this flange face is gonna be nice and parallel to this passive flange face that's not moving, all right? So that measurement there is 1/32 of an inch. We're gonna use this caliper here. Turn this caliper on, make sure it's at 0, right? And then you're gonna go around. How to measure this, you're gonna go around here, you're gonna see that these flat edges here on either side, that's what's gonna stick in the flange, right there, right? So all you're gonna do is make sure that you're within 1/32 of an inch all the way around. So you would take your measurements on all 4 points, right? And then you would take your highest measurement and your lowest measurement and divide those to make sure that you're within that 1/32 of an inch, right? So go ahead and do that.
I'm used to millimeters.
You could do it in millimeters too. That's perfectly fine. Yeah.
So what would that be? 9, 8, 8
8. Yeah. Correct.
Confused me there.
That's fair, that's fair. Fractions are no fun anyway.
No.
So we've got 20 more.
Yep. So he just set it to millimeters. That's perfectly fine.
You write that down on bolt 1.
Bolt 1. So label it as bolt 1, and also label up top there as this is going to be. Yeah, you're before you're past 1, so this is just when you're dressing the flange. Yeah.
20 millimeters. That's 19.
19? Millimeters are so much better.
Bolt 4 is 19.
So already you know that you're within that tolerance, right? So if everything's nice and flush and we're starting to get secure, right, we can make sure that all of these are snug tight, and then we're going to set up our MXT Plus with our washer driver system. Now, since these washers are back here on the nut side here, right, they do have some play to them. So as we're snugging these up, we want to make sure that we use our washer driver system to align the nut and the washer. So we're making sure that we use this to align the nut and the washer, right? And again, this is now becoming your reaction point. So it's pinch free, nobody severs fingers anymore, right? It gives you a nice axial load as well. Everything's on the same axis, gives you that nice axial load, and your reaction point is very safe. Now the socket that's inside of here just turns around. You can turn it with your finger, right? So what you do is just go around this entire flange, making sure that it's nice and snug tight, and that the washer lines up with the nut, since there is some play with the washer. Right? So go ahead and do that. Just go around and make sure that we can get this on. You can start snugging from the back side too. All right, so he went around the entire flange. He made sure that using the washer driver system, all the nuts are gonna line up with the washers. Using that washer driver, everything's gonna line up, won't be out a little bit. There is, some play in these washers to put them around different size nuts, studs here, right? So we want to make sure everything's nice and secure within there. Right now they're gonna be setting up, we're using our MXT Plus tool. This is the MXT Plus 1. These do have quick connect couplers on them. You can do it.
Of course the first one goes on smooth.
There might be some residual pressure in there. Depends on who used the tool last. As you can see, the tool's already set up with our safety handle. We're always going to use the safety handle. We're never going to grab the reaction arm. When we're using the washer driver system, we don't have to have a reaction arm, which is nice. So it's pinch point free. And then just show them what we're looking for on the spline there. We're going to be looking for what's called a spot face. It's a rounded out area. All right, that spot face here, you're going to align it with your thumb screw. There you go. Now she's just snugging that thumb screw onto that spot face, and then she's going to challenge it just to make sure that it's properly on there. It's not going to come off. Right? The other thing to note on these tools, one side is going to say tighten, right? The other side is going to say loosen, right there. The side opposing your socket that you are reading is the function that you are doing. So now that they're going to set this up on the ground first to set their pressure, once they set it up onto the flange, they'll know that they'll actually be in that tighten mode. So they will be tightening, they will be turning to create that torque, right? So we're gonna put this on the floor. You always wanna put it on the floor just in case anything happens, it leaks out or it starts to fall, right? Always just put it on the floor as you're setting your pressure. Now we are going to a max value of 700 foot-pounds of torque onto here, and we are gonna do our passes. So we're gonna do pass 1 at 30% of that 700. So they're gonna use our calibration chart here, and they're gonna look to see what that 30% of 700 would be, and that way they know where to set their pressure, all right? So here you go, guys.
So you're looking at Newton meters, and we're dealing in foot-pounds.
Well, you could do Newton meters
Or if
too.
we're gonna set to bar.
Right.
So either these two or these two.
Okay. It's only either one the same 100,000, 4,200.
So you would look up here, right? Your minimum torque value in foot-pounds is 205, right? 219 is the next value at 1600 PSI, right? So that's under a 100 PSI difference. So you could extrapolate these numbers, or since we're going to 210, since that's 30% of 700, well, you want to set it at as that 1600 PSI, right? The 1600 PSI, it's going to be very slow to get to, or very quick to get to, sorry, because these pumps, they idle at 1500 PSI, right? So doing that 1600 PSI, we're really just double checking to make sure that we're hitting this value. So we're still going to set it to that. We're going to go all the way around because that is that 30% value of that 700, right? Typically in our passes, you want to do either 20 to 30%, and then your pass 2 would be 50 to 60%, and then pass 3 would be your 100%. Right? So your 100% of the torque value specified for that application. So when we were going through it, we just did 30% of 700, which is 210. We see our lowest value is 205 on that torque chart specified for our MXT Plus 1 tool, right? So we always want to make sure that we're using the correct torque chart for the correct tool, because these torque charts are specified for these tools, right? So now he's got it plugged in. Everybody's wearing their safety PPE. We have our steel toe shoes on, our gloves on, our glasses on, right? So we're going to make sure that everything is good to go. And now we're going to build up the pressure. And how he's going to do it, he's going to turn the pump on using the green button here on the remote. If you want to just show him that real quick. Want to show him the remote? And then he's going to be using the pressure regulator to set that pressure. So he's gonna hold that green button down, press and hold that green button down, and slowly turn the pressure regulator clockwise to build up pressure. Now he's just locking the wing nut in. There's a lot of vibration that these pumps cause, so he's locking the wing nut inside to make sure that that regulator doesn't vibrate loose or move on them, so that pressure stays where it has to. Right, so he just set it to 1600 psi, right? Was it 1600? Yeah, so you just set it to 1600 psi, and that's going to give you your 219 foot-pounds. 210 foot-pounds is what we were looking for, right? But it's going to be within that plus or minus range. So now we're able to secure the tool onto here. So we're going to have our pump operator and our tool operator. What their main thing to do right now is going to be communication. So if the tool is being taken off of the flange at all, you want to turn the pump off so you can communicate nice and easily. You don't want to turn the pump on or activate the torquing process until Molly says that she's good to go on here. So the pump operator will say that he's clear because he's ready, and then the tool operator will say, I'm clear on here because I have everything set up properly and I'm in the safe zone. The best practice to do when you're doing these, stay away from the flange. Always try to stay on the side of it, right? Especially with this washer driver system. It really stays onto the flange pretty nicely. So you don't have to put a lot of force on there. She's gonna use the safety handle. She's gonna make sure that the hoses are nice and out of the way. And also on the coupler side here, she's gonna make sure that that screw is always facing downwards or away from everybody. Now underneath the sticker here, it always just says up. And that's just for safety precautions, right? Okay. So they can work on their signals now with each other and just making sure that they're gonna use proper signals with each other and that they're gonna be able to communicate.
So I'm clear. Yes.
You tell me go, I press pre. You say release, then release.
Okay. Are you gonna watch the gauge for me?
I'll watch the go.
Okay. Oh, you want me to tell you advance in the track? Oh, retract, advance, retract, advance, retract, advance.
Through the washer driver system here, we do have some windows so you can see the socket moving. Sometimes a little bit difficult with the lighting, but you'll be able to see that socket moving on here, right? As that nut starts to get to its torque value, it's gonna get tighter and tighter and tighter. It's gonna move a little bit slower, right? So what he's doing as a pump operator, he's paying attention to the gauge to make sure that they're hitting their correct torque value on that gauge. All right, so on to the next bolt here. And what they were both doing is making sure there was no more movement in the nut and that the gauge was stopped at its proper torque value, that 1600 psi that we had it set to.
Clear. I think we're still getting a little movement. Yes. Clear. Okay, good.
Now, also what she's doing, she's making sure that as she's putting the system on, she stays nice and flush against the washer and against the flange face, right? You don't want to be too far out because now you're not using that reaction washer system. So you want to make sure you're nice and flush against it. Right, you can see that it's not taking her much effort to hold this on there using that safety handle. Right, she's off to the side in a very comfortable position. That's a nice, safe position. Your hands aren't anywhere by it. You're not, creating any kind of pinch point or by any kind of pinch point.
Clear.
Now, if you see this hesitation in the gauge, right before it goes up to that 1600, it's that needle. That hesitation is making sure that that nut, or it's telling you that that nut is still rotating before it hits that torque value. We'll be able to see it a little bit later, especially on pass 3 when it's a higher value. So we'll point that out again.
Cool.
Thank you.
Stop.
Clear. Clear.
All right, so we're going to end the YouTube live here right now, but basically we're going to continue to work on this process. This is just to give everybody kind of an idea of what to expect out there and what kind of exercises and what kind of training classes we have here. So remember, if you want to take an ASME class, go to HYTORC.com/training. I got it right that time. Reach out to us if you would like to take one of these ASME classes. These two are actually taking this class, so we're going to continue with this process. We're going to end the live now. This was our first YouTube live, so I hope everybody liked it, and catch us for the next one.
Enjoy.